Hello everyone, my name is Madhurika. I am from Electronics and Communication Engineering. My roll number is 24951804448. Today my OOPS concept is Object Programming on CAD, Computer Aided Design, Object Oriented Programming for CAD, and Object Oriented Programming is a programming paradigm that organizes software design around data or objects rather than functions and logic. In OOP, objects are instances of classes which define both data and methods. This paradigm is highly suitable for complex systems like computer aided design CAD applications where the modeling of real world objects and their interactions is crucial. In OOP, key principles such as encapsulation, abstraction, inheritance, and polymorphism are used to create systems that are modular, flexible, and scalable. OOP offers a powerful way to manage complexity, especially in complex software like CAD systems, which need to handle sophisticated models, designs, and user interactions. What is CAD? Computer aided design (CAD) refers to the use of computer software to assist in the creation, modification, analysis, or optimization of a design. CAD software is widely used in fields such as engineering, architecture, industrial design, and entertainment for creating detailed 2D or 3D models of physical objects. CAD tools help designers produce accurate representations of structures, mechanical parts, and other objects, often simulating their functionality or behavior. Computer aided design (CAD) refers to the use of computer software to aid in the creation, modification, optimization of a design. CAD software allows designers, engineers, and architects to create precise drawings, 3D models, simulations, and more. The software enables the creation of representations for a wide range of objects from simple 2D sketches to highly detailed 3D models and is an essential tool in various industries including mechanical engineering, architecture and product design. CAD systems must handle complex geometries, relationships between components and multiple perspectives making them ideal candidates for an object oriented approach. Why use OOP for CAD systems? OOP brings several distinct advantages to CAD systems, making them more efficient, modular, and easier to maintain and scale. Here is a deeper look at why OOP is beneficial for CAD development. First one, modular design and maintainability. OOP promotes the creation of smaller, self contained modules that can be developed and maintained independently. Each CAD object, such as a circle or rectangle, is represented as an individual object that can be easily modified, updated, or extended. If a change needs to be made to the way a shape behaves, for example, changing the way the area is calculated, it can be made in one place within the object's class, and this change is automatically reflected whenever the object is used. This modular approach makes it easier to develop complex CAD systems by breaking down large intricate tasks into manageable pieces, reducing the risks of errors and making debugging and enhancements easier. Second, reusability of components. One of the most significant advantages of OOP is the ability to reuse code across different projects. For example, once you have defined a circle class with methods to draw and manipulate the circle, you can use that class in every design that requires a circle, saving time and reducing duplication. In CAD, reusable components might not only be geometric shapes but also common operations or features like transformations, Example scaling, rotating, or even more complex operations like 3D modeling, animations, or simulations. Third one, inheritance for extensibility. Inheritance in OOP allows a new class to inherit properties and behaviors from an existing class, enabling code reuse and extension. This concept is particularly useful in CAD systems where a large number of related objects share common features but also require specific specialized functionality. For example, consider a shape class that defines properties like position, color, and methods such as draw. Specific shape types like circle, rectangle, and polygon can inherit from the shape class and override or extend the functionality to meet their particular requirements. Example draw for each shape type will have different implementations. Inheritance allows CAD systems to manage relationships between objects more efficiently, making it easier to add new shapes or features without reinventing the wheel. Fourth one, polymorphism for flexibility. Polymorphism allows objects to be treated as instances of their parent class while enabling different behaviors for different subclasses. In CAD, polymorphism can be used to manage complex designs that involve various types of shapes and components. For example, a method like draw can be called on any object that is a type of shape. If the object is a circle, it will call the draw method specific the circles. If it is a rectangle, it will call the draw method for rectangles. Polymorphism ensures that CAD systems can handle a wide variety of objects and operations using a unified interface. Fifth one, abstraction for simplified user interactions. Abstraction is a practice of hiding the complexity of a system while exposing only the necessary features to the user. In computer aided design, abstraction allows users to interact with objects and features without needing to understand the intricate mathematical models or data structures behind them. For instance, when designing a mechanical part, a user interacts with simple high level geometric shapes like circles or squares in the interface rather than dealing with complex mathematical formulations. OOP allows for the abstraction of these details into objects, making the system more user friendly. Challenges of implementing OOP in CAD systems. Despite its advantages, implementing OOP in CAD systems is not without challenges. First, it increased complexity. While OOP helps manage large and complex systems, it also introduces its own complexity. Designing the class hierarchy, managing relationships between objects, and ensuring that the system remains maintainable as it grows can be difficult. For large CAD systems, carefully planning the object model is essential to avoid excessive complexity. Second, performance concerns. CAD systems often handle large data sets, especially in 3D modeling and simulation. OOP introduces some performance overhead due to object creation, inheritance, and method calls. Handling millions of geometric objects in real time can be computationally expensive, which requires optimization strategies such as caching or more efficient data structures. Third one, learning curve. The use of OOP principles in CAD software requires a solid understanding of both the CAD domain and object oriented programming. Developers must be proficient in creating and managing complex class hierarchies, while users must understand the interface and how to manipulate objects within the design environment. The learning curve for both groups can be steep. Application of OOP in CAD systems. Many modern CAD systems leverage OOP principles to improve functionality, flexibility, and user experience. Here are some real world examples. AutoCAD. AutoCAD uses an object oriented approach for both its user interface and underlying code. It defines geometric entities like lines, circles, and arcs as objects. These objects are instances of specific classes with predefined properties and methods, allowing users to interact with them intuitively and manipulate them in complex ways. SolidWorks. SolidWorks, a 3D CAD software, employs OOP principles to handle parts, assemblies, and features. The software defines a part class with methods for creating and modifying parts, while the assembly class manages the relationships between different parts. Inheritance allows for a high degree of reuse, where a base part class can be extended for more specialized components. Challenges of using OOP in CAD. While OOP offers significant advantages, there are challenges. Complexity. Implementing OOP in CAD systems can increase the overall complexity of the software. Designing class hierarchies, managing dependencies, and maintaining the relationships between different objects can require careful planning. Performance overhead. CAD systems often work with large datasets, and the additional layers of abstraction introduced by OOP can sometimes lead to performance issues. For example, handling millions of individual objects in a 3D model can be computationally expensive. Learning curve. Developers and users must understand both OOP principles and the specifics of CAD systems. The initial learning curve can be steep, particularly when dealing with complex modeling and object interactions. Conclusion. In conclusion, object oriented programming provides a powerful foundation for the development of modern CAD systems. By leveraging key principles like encapsulation, inheritance, and polymorphism, OOP enhances the modularity, reusability, and flexibility of CAD applications. While there are challenges associated with implementing OOP in CAD, the benefits far outweigh the drawbacks, making it an indispensable part of software architecture in the field of design and engineering. As CAD systems continue to evolve, OOP will remain at the core of their development, enabling more efficient, scalable, and user friendly solutions. Object oriented programming continues to be a vital component in the development of modern CAD systems. With its focus on modularity, reusability, and maintainability, OOP makes it easier to build complex systems that are flexible, scalable, and easy to modify. As CAD software evolves, incorporating new features like artificial intelligence, real time collaboration, and cloud computing, the principles of OOP will continue to play a central role in shaping the future of design technology. By combining the power of OOP with the sophistication of CAD systems, designers and engineers can create more efficient, scalable, and user friendly tools for a wide range of applications from product design to architecture and beyond. Thank you.